Hello and welcome to the Slackware ARM YouTube channel. We've got myself, Stuart Winter, the platform architect of the ARM port of Slackware, and we have Phil. Hi, Phil.
Hi, Stuart.
How are you doing, Phil? You okay?
I'm very well, thanks. How's yourself?
I am all good, thank you. Very good. Phil is the maintainer of SARPI, which is Slackware ARM on a Raspberry Pi. So it's a set of installation documentation and tools and support to get you running Slackware ARM on the Raspberry Pi, and that's part of the community support. So in today's episode, Phil, I thought what I'd do, so I have an update that I need to push out. There's a package there. So I'm going to show you that, and I'll show you a little bit about the build system that I use as well. That sounds good to you?
That sounds fantastic.
Good. So Phil and I, this channel is really about how Slackware ARM is developed, and we're also going to be talking about in future episodes how the AArch64 port is being developed as well. And Phil's really interested in how the operating system has been built. And you've also been working on 64-bit as well, haven't you, at one point for SARPI?
Yes.
So we'll talk about that at some point as well, because I'm going to use some of the work that you did there to get myself going as well. So let's get into this then. So Slackware ARM 14.2 was released in 2016. And this is what's called a software floating point port. It's 32-bit soft float port. What that means is that the actual physical hardware doesn't have a hardware floating point unit. So the effect of that is that if you were using, say, multimedia like videos and things like that on Slackware ARM 14.2, it wouldn't be as optimal and you wouldn't get the best experience because the mathematics involved in doing those types of operations has to be done in software rather than being offloaded to a hardware processor. So the Slackware ARM 14.2 release is a software floating point port. The reason for that is because the actual hardware, the original, the ARM hardware didn't have an FPU on it. So that's why it just wasn't there. And so the port was software floating point. So Slackware ARM, what's now the development branch, which will become Slackware ARM 15.0, that's a hardware floating point port. So there are newer pieces of ARM hardware which have a hardware floating point unit, and what will be Slackware ARM 15.0 is able to make use of that hardware floating point unit. So things like video processing and those types of activities will be faster on there than 14.2. That said, if you're using Slackware ARM 14.2 like I am on my home server, for things like NAS, NAT, Internet NAT gateways, things like that, you really can't notice any difference. It's actually perfectly fine. Those types of operations don't need hardware floating point. The aim with Slackware ARM is to support the previous stable release and the current development branch. Unlike with Slackware x86, which supports the previous releases, sometimes for years after it was released, several years in some cases. So what we're going to look at here today is updating some packages for Slackware ARM 14.2. Slackware ARM follows the update stream of Slackware x86, which are typically security patches or sort of bug fixes or just general updates. There aren't a huge amount of them. Now, what you see on the screen here, this machine here, Zaden142, Zaden is just the name of the machine. Whenever I do a Slackware release, there is a physical machine that is assigned to a release of Slackware, and it gets installed, and that's it until it's end of lifed, until that particular release of Slackware ARM is end of lifed. And so I've got here Zaden142. So I know which machine it is, I know which version of Slackware it is when I log in. Now, this particular machine is what's called a Marvel Shiva plug. That's the machine is called a Shiva plug. That was the type of device. It was released in 2009 by Marvel. The company called Marvel. They make lots of ARM embedded devices. You find Marvel in, say, Dell switches. So, for example, my Dell switch that's in my house that I use for my LAN is actually has an ARM processor in it, made by Marvel. So Marvel were making use ARM in embedded devices, and Shiva Plug predates the Raspberry Pi the original Raspberry Pi. And in my opinion, it was far better than the Raspberry Pi, which is why Slackware ARM never supported the Raspberry Pi initially, because the hardware just wasn't as good as what I already had, so it didn't make sense. So this machine is a Marvel Shiva Plug released in 2009. It's a 32-bit ARM v5 machine. As I said, ARM v5, it doesn't have hardware floating point, so the entire operating system is compiled for software floating point. And in fact, this particular machine that I'm logged into here is one of the few, in fact, it's the only ARM v5 machine I still have running. I have a box of them, but through the years, the power supplies have broken and things like that. And because I only do updates for the software floating point ports for 14.2, I don't need lots of old ARM hardware running anymore. But this particular machine has actually been cannibalized. It's been kept alive through cannibalization of other bits of ARM devices like the power supplies and things like that. Maybe at some point, for people who really love looking at pictures of hardware, I'll take a picture of it in all its glory with PVC tape and things like that that are keeping my soldering jobs together. So Slackware ARM 14.2 was actually built on a number of these Shiva plugs. I had a number of them, I think 3 or 4 at one point when I was building Slackware ARM software floating point port. And this is the last one that's remaining. I'll show you a little bit more about this. It's just as I said, this is my stable build machine for Slackware ARM 14.2. As you can see, I have some local storage here. If I remember rightly, this is a USB, this is a regular 3.5-inch spinning disk in a USB caddy that's attached to the Shiva plug. And it's 150 gigs or something like that. And so it has a full installation of Slackware ARM 14.2 on it because Slackware is built on a full installation. So that's why there's 25 gigs used on it. Plus the fact there's probably loads of leftover residue from various builds that I just haven't tidied up. Now, as you can see, it's also been up for 74 days. The machine is stable; it will stay up for years. The only reason that this machine is rebooted is if I upgrade the kernel. I push out a new kernel package, or the power gets cut. That's pretty much it. Other than that, the machine stays up at this time. As you can see, I've even been logged into it from one of my other development machines for 20 days. So I tend to keep everything up and I just log in and make the changes. As you can see, it's running Linux 4.4, which is the LTS release of Linux. So it's a long time stable release. So it's going to be maintained for quite some time. I also have another machine that runs Slackware ARM 14.2, as I said, which is my home gateway machine for the internet. And that is a Banana Pi, which is actually ARM v7. So that is a machine. The Banana Pi has a hardware floating point in it, but it's running the software floating point port on it. So it doesn't make use of that hardware floating point. Once I release Slackware ARM 15.0, I will upgrade that Banana Pi and it will run the hardware floating point of Slackware ARM as well. Of course, this machine here, and this is really important to note actually, for those of you who are running Slackware ARM 14.2, you will not be able to upgrade from 14.2 to 15.0. There is actually, I'm pretty certain, in fact, let's have a look. Oh yeah, there we go. So when I started the Slackware ARM hardware floating point port, I've already made the note here that if you're running Slackware ARM 14.2, you won't be able to upgrade to 15.0 because the actual application binary interface is completely different. They're not compatible at all. So if you've got an ARM v7 machine, you will need to reinstall it from scratch. Now, the really important thing about this is that, as you can see here, this machine is an ARM v5 machine. It will not run Slackware ARM 15.0. As I said, I will end of life Slackware ARM 14.2 after 15 is released. If you have one of these machines, you can't upgrade it. Just make sure, if you want to keep running it, that it doesn't have remote access to it, because I will not be providing any security updates for it at all after that time. So what do we need to do? Well, the first thing is, let's just show you what's going on with the build system, so you get an idea of what's under the hood. Now, this is the Slackware ARM website. Yes, I know it needs TLS. I will get it fixed. And this here is called Beehive Glimpse. It provides a glimpse into what some of the Slackware ARM build systems are doing. And as you can see, we have Xaden 142 is represented here. Now, so just so you know, this particular section will be moved into a different part of the website as I develop the AArch64 port, because I will have more machines and it will simply make the web page way too big. So I will reorganize this at some point. But this just gives you an idea of as to what the Slackware ARM build machines are currently doing. There are more of them, but there are only 3 that are represented here because those are the main ones that I use. And in fact, the only reason that this is actually even here at all is because when I used to travel to London to visit clients on the train, I had an hour or so train journey, and I wanted to see what my machines were up to. So I could just go on my phone and have a quick look and see what was going on. I just quite like doing it, so I put it there. Now, you can see here that the machine has been up for 10 weeks. As I said, it's pretty stable. And you can see that there's what's called in-queued activities. And what does that mean? We'll have a look at that in a moment. You can also see zippy.arm.slackware.com, which is the lead build machine for the Slackware ARM current branch, which will become 15.0. And you can see that the build system has been building things, and it's completed, but it found an error with glibc. I've already fixed that. But it hasn't. I'll show you this in future episodes. I've already fixed it, but I built it outside of the build system, so the actual failure hasn't been, the correction hasn't been detected here. Okay, so let's switch over back to the Slackware ARM 14.2 build machine. All good with you, Phil?
Yeah, everything's great. It's really interesting how you've maintained and coped with everything. It's a bit overwhelming.
There is a lot to it, yeah. You know, if you're going to maintain a distribution, you have to have lots of tooling around it. Otherwise, you spend a lot of time just doing things manually. Okay, so here we are in the master Slackware ARM 14.2 directory. Now, I'm going to show you this. I've got to say, I'm sure some people would be saying, Nano, he uses Nano. It's blasphemy. What about Emacs or Vim? It's quite funny. Actually, I was introduced to Pico when I first started Unix, and I loved it because it was very similar to the editors I was using. And actually, I really like Nano. I can use Vi as well in Anger, but I actually really like Nano. It works perfectly well for me, particularly with the color coding. I really like that. So you can see the changelog here. And, you know, most Slackware users will be very familiar with the changelog. So as you can see in the changelog, there's 2 markers here, **CL and **CL. So we've got opening and closing markers. It's a bit like XML, the way I've done this. This particular text here is the update that I need to push out. Now, as you can see, there's some pluses inside of this. I'll show you how this works in another episode. But for now, I've actually already upgraded the glibc zone info package inside of Slackware ARM 14.2. The only thing I haven't done yet is actually push the changes out. So this changelog isn't quite ready to go out. Now, I have a handy little tool called compcls, which means compare changelogs. It's difficult to say, compcls. Now, what this does is it compares the local Slackware ARM 14.2 changelog to the one that's on the public internet on the FTP servers. And as you saw on the website, there were some in-queued activities. Well, that's just a message that means I've got some stuff waiting for me to do and deal with. And this here is telling me that it's out of sync. The local copy is out of sync with the public copy, and it tells me what the differences are. So yes, I've got some work to do. What I'm going to do now is run the changelog script. What this does is this generates what will become the changelog that gets made public. The way this actually works is if you look here, there is a file called changelog.stamp. And if you look in the public FTP site, you'll see the absence of this file. This is one of the many files that don't make it to the public repository for a number of reasons, and we'll cover that as we go into subsequent videos. But you'll see the timestamp here. Now, the changelog script, it does a few things, but the way it generates the package list is very, very simple. It simply looks for Slackware packages that are newer than the last modified date of this file. It's as simple as that. Let's run it and see what happens. Now, it takes a couple of moments to generate that. It's also syncing its own clock with an NTP service, because one of the things about some of the ARM devices is that if they don't have an onboard real-time clock, they can get clock skew. And usually, to be fair, it's only a few seconds, so it doesn't really matter. But the thing is, if I've been very busy building packages, it could mean that it actually misses a package if the clock skew's gone, hideously wrong. But typically it doesn't. But that's what we do. So everything, whenever I run any operations in the SlackwareARM build system, there's always an NTP time sync prior to doing that. Okay, so the changelog script has run. As you can see here, there's a little handy ruler, which actually came from, I think, one of Patrick's scripts, which allows me to keep the changelog entries up to this particular line length so that it fits in regular terminal windows, at least old school size terminal windows. What I'm going to do here, I'm not going to go too much into the changelog script here. There's a few little things, like, as you can see, it also creates a backup and then it deletes it once this is finished. A backup's pretty helpful because if I've made any mistakes or something, I can just go and grab it from the backup. So it makes my life easier. And there's a few little bit of other information here. I'll show you that in a subsequent video, what that's all about. So all I'm going to do, pretty straightforward. I'm literally just going to delete the text. I don't know what is going on here. This here, as you can see, is just space. I've tried to fix this bug forever and I can't fix it. And this only happens on SlackwareARM 14.2. So I'm thinking that there must be something to do with some of the tool sets where it's inserting spaces, because it doesn't happen on SlackwareARM current. It never has. So I'm not going to fix that bug because I'm going to end of life 14.2, in the near future anyway. But there we go. That's the changelog. It's updated, and we're going to save it. You see here, there's a little bit of warning messages coming out here. That's just because I just haven't fixed that yet. It hasn't bothered me enough to actually fix it. What the changelog script also does is that we have these mini root file systems. The mini roots was really for me as a way to easily get Slackware onto a new ARM device. And the changelog also detects whether the mini root file system has been rebuilt. And if it has, it makes a mention of it in the changelog. So it's all automated. But there's just a little scripting error there. So it just pops up a warning. It doesn't actually cause any damage. So that's there. The last thing is we're going to go and then stamp that changelog.stamp that I showed you before. You can bail out with Control and C if you don't want to do that. And boom, it's done. So now, text. Yep, that's the changelog for 14.2. Okay, so what we're going to do now, we've updated the changelog and we need to push out the distribution to the FTP side. So we're going to run this script called prep for distro, and it asks me a question: do you want to push what you've done out to the FTP sites after we've finalized everything? Well, yes, I do. Next thing is, which distribution trees do you want to work on? Do you want to prepare? As you can see, I've got a few choices. I've got Slackware ARM 64 current. We're not pushing that one out today. And we're not pushing out Slackware ARM current because that is not ready to be pushed out at this moment in time. But we do want to push 14.2, so let's select that one. So what we're going to do here is run the make tags and make txts. The make tag script generates the tag files for the installer. It's basically just an installation recipe list saying which packages should be installed. It's the defaults. So when you go into the installer, the ones that are selected versus the ones that are deselected. The reason why we need to run this script here and not just take the ones from x86, which we could do, is because the Slackware ARM port has some additional packages. And likewise, it also has some packages removed from it. So even though it's a full port of Slackware to the ARM platform, it does have a few packages that had to be removed because either they wouldn't build on ARM or they were just for x86 only, like, for example, Lilo, syslinux, and some other things. So we need to regenerate our own tags there. Make txt's, all that really means is that it creates the package txt file. So when you look in the directory structure, you'll see the txz Slackware binary packages and also a txt file. The txt file is literally just the description of that file. The reason why we have it is because it allows package tools, if the file is there, to quickly show you the description of the package rather than unpacking the package and finding the description that way around. So it's just a faster way really of having the package description available. You don't actually need them to install Slackware. In fact, when I install Slackware ARM, I actually install it from the master tree, which doesn't have any of the TXTs. So what it's currently doing is running those two scripts, and that does take a few minutes. It does that inside the main Slackware directory first, then it moves into extra, and then it moves into all of the other directories like testing and pasture as well. So we'll just let it do that for a moment.
So where does the hash file get created for the package?
What hash file?
You know, when you look at any package in the Slackware directory, there's a text file and a package file, and there's also a hash file that accompanies it.
Aha. Oh, the GPG signature. I think that's what you're referring to, isn't it?
Right.
You mean the ASC file?
Yeah, ASC, that's what I was trying to think of, sorry.
Okay. Yeah, so that will be created by this. You'll see that in this script. So this script is, as you can see, isn't the fastest script in the world. It is actually running on x86-64 though. It could be improved if I used the tool called Parallel, which I think is a really interesting tool actually. A lot of what my build system does, at least with these types of scripts, could be improved using that tool. It's on my to-do list, but to be honest, it's not that slow enough for me to actually invest the time and go and fix that up yet. So what we're looking at here is this allows me to manually check what's happened and what the tree looks like, just to really check the status of it. What you're looking at here are the tag files that I mentioned before. So you see this option add, that means that the package would be automatically selected. And this one means that it's recommended, you should install that one. You probably really ought to. And it does that for each series or each package series or package grouping, if you want to call it that, within the distribution. I'm going to jump straight to the bottom. Everything looks good here. There aren't any missing packages. So this script performs a whole bunch of checks to make sure that the distribution is pretty much in sync with x86-64. It checks whether there are any packages that are missing that haven't been deliberately masked out. So I said before that not every package is present in the OS because it doesn't build or it's not for ARM. Those packages are in a list, so they're masked out, and this detects whether there are any missing that should be there that aren't masked out. So there's a couple of checks there. It then goes through, sets any permissions, resets them all to same defaults. I've got a couple of other checks here, things like unpacked Linux sources, because I've accidentally pushed an unpacked Linux source into the FTP site at one point in time, and that was, I had to go and delete it. These are things that I did. So there's little checks in here just to make sure I haven't left some residue in the file system. We're going to do a last sanity check. We're going to check that changelog is all up to date. So this just allows me to make sure I've actually written it properly and make sure it all looks good. It looks good to me, and we're going to push it out. So as I said before, I have a master tree, which includes, which is the one that I work on and includes some hidden files and other things like that we'll talk about later. What you can see here is that this process actually rsyncs the master tree onto what I call the public tree, and it does that locally. So this is just rsynced, from one file system to another on my local machine. And then what it does is it goes through and creates all the file lists, the manifests, the package lists, the checksums in each of the directories that contain Slackware packages. And then it's also going to create those GPG signatures that you talked about, Phil, as well. The reason it's done like that is because the file lists can't include anything that's not actually present. I take the master tree, rsync it, delete, exclude a whole bunch of private files, and then the file list is made on the public tree. So everything in the file list is actually present within that tree. So that's why it's done that way. The GPG signatures have been created during that process as well. And it's now live on the internet, on the FTP site. Okay, so we've updated the changelog. We have prepared it for release. We've now pushed it out to the master FTP site. As you can see here, this is the primary mirror for Slackware ARM, which is hosted by Darren Austin, one of the guys that I met years ago, actually, in Covlog, which is a Coventry Linux user group where I used to be. So he runs this service for Slackware, has done for as long as I can remember. And let's have a look at what's there. And there we go. So live now is Slackware ARM 14.2 with that update that we just pushed out.
Really amazing, Stuart. I'm very interested in the tools that you've designed and used to fulfill all this. Obviously, you'll know yourself, typing out commands 100 times to do what you do is time consuming and unnecessary when it's all built into the build process. But it's more, I mean, obviously we've spoken about this in the past. It is way more impressive and intricate than what I imagined.
No, so if you've got any questions later, Phil, just watch the video on YouTube and feel free to ask me, and we can talk about them in subsequent episodes.
I certainly will.
All right, and we're done. So I hope you enjoyed that video in seeing the insights into how I maintain the Slackware ARM 14.2 system. Please like and subscribe to the channel. We'll be updating videos reasonably regularly, particularly as we move into the AR64 port. If you've got any ideas or suggestions or queries or comments, let us know in the comments section. Thanks a lot. That's goodbye from me.
And goodbye from me.
All right. Cheers, Phil. Take care.
Thanks, Stuart.